Welcome students, welcome to Made Simple. In today's lecture, we are going to study about motion of CAM terminology and derivatives of forward motion. So, if a CAM is rotating, then in that case we have four types of motion: angle of ascent, angle of descent, and angle of dwell and angle of action. So, first angle of ascent, which is represented by alpha. It is the angle through which the cam turns during the time the follower rises. Angle of ascent is this. In this figure you can see. Yes. So in this figure you can see angle of ascent is this. This is the cam profile. I'll draw the cam profile in green. This is the cam profile, and this is the angle of ascent. The angle of dwell is the angle through which the cam turns while the follower remains stationary at the highest and the lowest position. Highest or the lowest position. So angle of dwell is this portion here, from here to here. Now angle of descent, it is the angle through which the cam turns during the time the follower returns to its original position, to its initial position. So angle of descent is this one. Now angle of action. The angle of action is the total angle moved by the cam during the time between the beginning of rise and the end of return of the follower. So the beginning of rise is here. I'll mark it in red. Yeah, this point. And it is between the beginning of rise and the end of return. So end of return is here. So we have this angle is angle of action from here to here. So that's the motion of CAM terminology. Now we come to derivatives. I hope you have understood this. And this is the graph that shows CAM rotation and follower rise. So this is angle of ascent from here to here, from here to here. This is angle of ascent. Then we have dwell. Dwell is here, and then we have angle of descent. So like that we can plot a graph between rotation and follower rise. Now we come to derivatives of follower motion. Derivatives of follower motion are of two types: kinematic, it relates to the geometry of the CAM system, and derivative is done with respect to theta. Physical, it relates to motion of follower of the CAM system. It relates to the motion of the follower of the CAM system. Now, kinematic derivative. Follower motion is plotted with cam angle theta as the abscissa and the follower linear or angular motion as the ordinate. Now let S is equals to displacement of the follower. Mathematically, S is equals to S theta. Now theta is the angle that is rotated by the cam. Angle that is rotated by the CAM. Now S theta represents steepness of the displacement curve or slope of the graph. That is what S theta represents. So we have, if S theta increases, it means a steep rise or fall happens to the follower. The second derivative gives S double theta, S double dot theta is equal to d square S by d theta square. If as in this case, if S theta becomes infinity, then the cam becomes pointed. So if S double dot theta, and this should be a dot here, yes, then the cam becomes pointed. It relates to radius of curvature of cam at different points along its profile. If S dot theta increases, if S dot theta increases, then the radius of curvature decreases. Now we come to the physical derivative. In physical derivative, S is equal to S theta and theta is equal to theta t. The first derivative with respect to time. Is S dot equal ds by dt, and ds, this can be written as ds by d theta by dt, which gives ds by d theta. This quantity is omega. And this, so this would become ds by d theta. Sorry, this would be omega. This would be omega, and which will give omega is also ds by d theta. Now S dot represents the velocity of the follower, as you can see. Now in the second, if we do the second derivative of S double S dot of the displacement, then we get d square S by dt square, which is omega square d square S by d theta square. This represents the acceleration of the follower. The third derivative, if we do third derivative of S, then we will get d cube S by dt cube, which is omega cube d cube S by d theta square. S triple dot represents jerk. So this is what is known as jerk. So that was all for today, guys. If you have liked the video, please do give a like, subscribe to my channel and share it with your friends. Thank you.